There are two major views in Segue: the network view and the ego network view. The network view shows a spatial layout of dynamic ego network. Each dot represents a dynamic ego network. Users can change the distance function for computing the distance between dynamic ego networks. They can also click on a dot in the network view to inspect a temporal visualization of the dynamic ego network in the ego network view. By hovering over the temporal visualization, users can inspect a static ego network at a particular time step. They can also click on the temporal visualization to store the ego network in the network view for further inspection. Let us consider how a network analyst can analyze the Enron dataset using Segue. Each dot in the network view represents the dynamic ego network of an employee. Darker dots represent upper-level employees. To begin with, she wants to understand the size fluctuation of the dynamic ego networks. She separates the ego networks that have a fluctuating size from those that have a stable size by creating two event types: size increases and size decreases. To create size increases, she selects the size time series from the context menu and sets the slopes to be greater than or equal to 0.36. To create the event type size decreases, she sets the slope to be less than or equal to negative 0.36. In the resulting spatial layout, some dots overlap with one another. Users can overlay a heat map on the spatial layout. Redder area means that there are more dots overlapped in that area. The analyst clicks on the jitter button to jitter the dots to reduce overlapping. Most ego networks maintain a stable size over time. They only have few blue and orange pixels. There are some outliers that have a very fluctuating size. Their event sequence visualizations have many blue and orange pixels. The analyst selects an ego network with a fluctuating size and an ego network with a stable size. From the size time series in the ego network view, the top time series really has more ups and downs than the bottom one. Next, the analyst wants to investigate the density distribution of the ego networks. She creates three event types: density between 0 and 1, density between 1 and 2, and density between 2 and 3. There is an obvious outlier. It has a lot of orange pixels, which indicates that it largely maintains a moderate density over time. Finally, the analyst wants to investigate the communication patterns in Enron, who are those who communicate a lot with CEOs, presidents, and vice presidents, and who are those who mainly communicate with the low-level employees. She uses the shortcut to create the event type. CEO appears in the ego network. Sally Beck is an outlier as she has many blue pixels, indicating that she communicates a lot with the CEOs. As the analyst adds another event type, President appears in the ego network, John Lavorato becomes another outlier. Both Sally Beck and John Lavorato communicate very frequently with CEOs and presidents. After adding Vice President appears in the ego network, Sally Beck moves closer to the other dots. This is because, like other employees, she does not communicate a lot with vice presidents, as indicated by fewer green dots in her event sequence visualization. Sally Beck is very interesting as she is only a very low-level employee but communicates a lot with the executives. We later found from her LinkedIn account that she was indeed a managing director rather than a low-level employee. The analyst adds two more event types. Trader appears in the ego network and employee appears in the ego network. The spatial layout seems to be divided into two halves. The upper half contains paler dots that represent lower-level employees, and the lower half contains darker dots that represent upper-level employees. A pattern of the lower half is that many ego networks have more blue, orange, and green pixels than red and purple pixels. This indicates that upper-level employees tend to communicate more with CEOs, presidents, and vice presidents. A pattern of the upper half is that many ego networks have more red and purple pixels. This implies that many low-level employees communicate with more low-level employees such as traders.